Okay, here we go. Page 47. Spoiler alert. Okay. Number 31 at the top of the page. We're going to phrase it like this. Let alpha, beta, and gamma be the angle measurements of a trigon. If alpha equals 4 beta and gamma minus alpha equals 90 degrees, then what? Their question is basically, can we conclude we're talking about an isosceles triangle? That's the big question. Isosceles? Is it an isosceles trigon? Now, we're not talking about side measurements here. We're talking about angles. So the goal is to check these angles and see if we have two angle measurements that are congruent. If we have two, they're the same. So we have gamma in 47a. The gamma minus alpha is 90. And alpha is equal to 4 beta. If alpha is equal to 4 beta and gamma minus alpha is 90 degrees, then, well, this means that gamma is 90 plus alpha. And that means that gamma is 90 plus alpha, right? But we know that alpha is 4 beta, so instead of alpha here, we're going to put 4 beta. Gosh dang it. Let me get this lens to focus. Focus lens. Is that sharp? I hope it's sharp. So I'm going to lock it and I hope it stays focused on the paper and not on this pencil. Sorry about that. It keeps going in and out. So, yeah, we have, so we know this. Well, gamma is 90. We'll take these parentheses off, plus 4 beta. And we know from the properties of every trigon in Euclidean space that alpha plus beta plus gamma plus all those angles, that adds up to 180 degrees. Now, since we know that alpha is 4 beta, we'll put 4 beta here. 4 beta plus gamma equals 180 degrees. That means 5 beta plus gamma is equal to 180 degrees. That means that gamma is equal to 90 plus 4 beta. We can take this right here and substitute it into there. That gives us 5 beta plus gamma, which is this thing right here, 90 plus 4 beta equals 180. Let's write that part of it. Take the parentheses off and we have 9 beta equals 180 plus this negative 90. I'm moving this over to the other side. So 9 beta equals 90 degrees. Beta is equal to 10 degrees. Beta is equal to 10 degrees. Alpha is 4 times beta. So alpha is equal to 40 degrees. And because of this right here, we have 40 and 10. That's 50 degrees. I have 130 degrees more to go to fill up that trigon with proper angle measurements. So that leaves 130 for gamma. All these angles are different. Cannot be an isosceles trigon. So 47A, no. Or the Polish, yeah. That's 47 or 31A on page 47. All right. Let's go to 47B, or page 47. 31B. 31B. Let's pretend we've done that. Well, we'll write it again. Let alpha, beta, and gamma be the angle measurements of a trigon. Of a trigon. So we'll say this is 31B. So if, so what situation do they give us here? I think it's if 10 alpha plus 6 beta equals gamma, and I think they say 2 alpha equals beta plus 10. Then, well, we'll figure it out. Then it's isosceles or it's not. So here's our if. This is 31A, the alpha, beta, gamma be the angle measurements of a trigon. If alpha equals 4 beta and gamma minus alpha equals 90 degrees, then that trigon, the trigon is not isosceles. Well, we're writing theorems. This is the name of the game. Like this. So here we have this situation. 10 alpha plus 6 beta equals gamma, and 2 alpha plus equals beta plus 10. So I suppose we could substitute this right here. We could solve for beta straight away. Beta equals 2 alpha minus 10. And over here, we can say, save this conclusion for later. I'm going to go down at the bottom. So here we have 10 alpha plus 6 times beta equals gamma. And we know that 6 times beta is 6 times this, because that's beta. So over here we'll put 2 alpha minus 10. So we have 10 alpha plus 12 alpha minus 60 equals gamma. And of course we have one other equation. We have alpha plus beta plus gamma equals 180 degrees. Here we have 22 alpha minus 60 equals gamma. Here we can say gamma is 180 minus beta minus alpha. Okay, so this is equal to gamma. And this right here is equal to gamma. And we do not, here we have just alpha. We can set these equal to each other because they're both equal to gamma. This is written just in alphas, with alphas. And here we don't need to write this beta like this, do we? We know what beta is. We can write it entirely in terms of alpha. So let's do that. So we have gamma is equal to 180 minus beta minus alpha. And because beta, from what's given up here, is 2 alpha minus 10, we can write gamma now, take these parentheses off, and we have 180. This negative 1 goes over here to make that a positive 10. So we have 180 and a positive 10, so that's 190 minus 2 alpha minus alpha minus 3 alpha. So that is what gamma is solely in terms of alpha. Here's another gamma equation solely in terms of alpha. So it'll be real productive to set these equations equal to each other. So 22 alpha minus 60 equals 190 minus 3 alpha. Oops. 3 alpha. Let's add 3 alpha to each side. So we'll add 3 alpha here. Minus 60 equals 190 minus 3 alpha. We'll add 3 alpha. So this just becomes 0 here. Negative 3 alpha and positive 3 alpha. That's 0. We have 190 plus 0 equals 25 alpha. 25 alpha minus 60. So let's add 60 to both sides. So this is 25 alpha equals 250. That makes alpha equal 10 degrees. Okay, so the question is, let alpha, beta, gamma be the angle measurements of a trigon. If we have this relationship between the angle measurements, these relationships between the angle measurements, what can we conclude about this trigon? Well, let's see. If alpha is 10 degrees, then beta is twice alpha minus 10. So let's just substitute 10 in there. Beta is equal to 2 times 10 degrees, what we found out here. That's 20 minus 10, which is 10. So beta is 10 degrees, alpha is 10 degrees. We have 2 angles, same measurement in a trigon. That makes it isosceles. So if this, then the trigon is isosceles. This is a statement proven true, which makes it a theorem. Because all these exercises you can kind of squeeze into this format. So that's 31, 31B. It doesn't quite get the whole paper, fortunately, and I ran out of space. I should put margins. I need another piece of paper. Okay, for 31C, they just say if alpha plus 2 beta equals 180, then what can we say? What can we say about the trigon? That alpha, beta, make sure this is focused. Gosh dang it. Focus is still locked. Okay, good. I'm doing something right now. I hope this is sharp and crystal clear. So we know this. If this, then what? Well, this is what we're given in the supposition. In the supposition, we're supposing something. Supposition. So if this is the case, we also know we're talking about a trigon here. So alpha plus beta plus gamma equals 180. Right? So gamma is going to be equal to 180 minus beta minus alpha. And we're just using those two right at the moment. Now we're going to use this. Because gamma is equal to 180 minus beta minus alpha, but we know what 180 is also equal to, so we're going to substitute 180. 180 is actually alpha minus 2 beta. So we're told. So gamma is equal to, let's take the parentheses off, minus beta minus alpha. We got a positive alpha and a negative alpha. That's the additive identity. That's 0. And we have, this plus. 180 is alpha plus 2 beta. So plus goes there. And we have 2 beta minus another beta is just beta. So this implies that gamma is equal to beta. So if this is the case, then the trigon is isosceles. Because we have two angles with the same measurement in this trigon. All right, that should do it for, what is this, 31. We're at the top of page 47 now, I think that's what's going on here. Okay, moving on to 32. We are to prove that in every triangle, there is an angle whose measure is not greater than 60 degrees and an angle whose measure is not less than 60 degrees. So we might phrase it like this: for every trigon, for any trigon, for each trigon. We're being told to prove this. Prove prove this. For every trigon, for any trigon, there exists an angle measurement alpha, which is not greater than 60. So not greater than 60 we'll write as less than or equal to 60. And in that same trigon, there's an angle measurement beta. I'm just using labels here, right? The power of let. And there's an angle beta greater than or equal to 60 degrees. So we are to prove this. Now, you can see by the paper here, we're going to prove it by contradiction. How would you know to do that? Well, you should always have this strategy ready to go. It's one of the most common types of proofs. When do you use it? Well, try it out. Sometimes instead of having a plan, proof by contradiction means you contradict it and then see what happens. If something crazy is the result, or if something paradoxical is the result, then your proof worked. Proof by contradiction. And something you should have ready as a strategy, but especially with something like this, where, like, what? You got to prove something for every trigon in the universe? That's asking a lot. That's a lot of trigons. It might be easier to just contradict it and see if something ridiculous happens. Then we know that we were wrong. Our contradiction was wrong. So we're going to assume the opposite conclusion. So assume there does not exist, let's say in any trigon or in every trigon. But of course, we're talking about trigons. Assume there does not exist an angle measurement less than or equal to 60, or there does not exist an angle measurement greater than or equal to 60. Okay, so this comes from logic. You have to know how to take off parentheses. So the hypothesis here is this and. So for every trigon, there exists an angle measurement less than or equal to 60, and there's also, at the same time, in the same trigon, together, there's an angle measurement greater than or equal to 60. That's what we're proving. So it has this form. It has P and Q. This and this. It's a compound statement. So we want to negate that. So to negate that, we're talking about the compound statement. So let's talk about the whole thing. We'll wrap it in parentheses here because we're talking about the and part of it. And we negate it. So that symbol goes in front. To take off these parentheses, we do this little switcheroo where this conjunction becomes a disjunction, and we distribute that not symbol. So these are logically equivalent, that and that. Logically equivalent. So this would be like, for example, Saturday I went to the park and I went to the cinema. And I went to the cinema. Park and the cinema. Okay? If I negate that, I say it is not the case that. That's how you translate these parentheses. They kind of not the case. Not the case. And then you say not the case. And then inside here, this is the case. So then you state your case. So it is not the case that on Saturday I went to the park and I went to the cinema. So for that to be true, for this contradiction to be true, to take off these parentheses, if it's not the case that I went to the cinema and I went to the park, then it's also true. It is the case that I didn't go to the park or I didn't go to the cinema. One of those trips didn't happen. One of those trips didn't happen, which is why I can't say both did. And so you might need some practice in basic logic, reasoning, and how to make arguments to get here. But I hope you get that for at least this problem right now. So that's why we have this or. So we're going to assume the opposite, and using the opposite involves an or because conjunctions switch to disjunctions. And so what is on either side of that disjunction? So there does not exist in any trigon an angle measurement greater than 60. So let's examine this case. Let's this or this. The opposite is this or this. So let's look at each one separately. So if it's true that there does not exist an angle measurement less than or equal to 60, that means let's see. Assume there is not. Assume A. We'll call this A, and we'll call this one B. So statement A. So if we're talking about this first part, an angle measurement, there does not exist an angle measurement less than or equal to 60, then if A is the case right here, then alpha is greater than 60, beta is greater than 60, and gamma is greater than 60. Because we're assuming there does not exist an angle less than or equal to 60. That means they all got to be greater than 60. Say for any alpha, beta, gamma, or for any trigon. For every trigon. So that means alpha plus beta plus gamma is greater than 60 plus 60 plus 60. So that means alpha plus beta plus gamma is greater than 180. And that's impossible. That's a contradiction. Contradicts the 180 trigon. Contradicts 180 trigon theorem, which was something proven true. 180 degrees for all the angles in a trigon. That's proven true. That's a theorem. It's proven true. It's true. There's no contradicting it. You go against that in Euclidean space and Euclidean geometry, you're wrong. So this was wrong. Is the whole thing wrong? So all we have to do is check the other thing, the other condition here, the other part of the disjunction. If we're talking about B here, if B than alpha. So we're talking about there does not exist an angle measurement greater than or equal to 160. That means there is no angle measurement greater than or equal to 60. That means alpha is less than 60. Beta has got to be less than 60. Because we're saying there's not any greater than or equal to 60. So that means gamma also is less than 60. Oh, I'm running out of space here. So that implies gamma or alpha plus beta plus gamma is less than, strictly less than. So here, like strictly greater than, strictly less than 60 plus 60 plus 60. That means we add up all the angle measurements of this trigon and we get something less than 180. That's a contradiction. That's an absurdity. That's absurd. This is the technical thing you're going for. Technically, you're going for absurdity. Absurd. It means ridiculous. That's ridiculous, right? You can't have the angle measurements adding up to less than 180. I think it's called reductio, proof by contradiction is reductio ad absurdum. So they really use something like absurdity. So we get an absurdity. That's crazy. That's to be proved. So we proved it because this has to be the case, that there's an angle less than or equal to 60, and at the same time, in the same trigon, there's an angle greater than or equal to 60. This has to be the case for every trigon, because we showed that if we contradict this, if we assume the opposite, then we get something absurd, something ridiculous. We get triangles with greater than 180 degrees, or we get triangles with less than 180 degrees. Proof by contradiction. So use this. We'll just have it ready. This is just very common. It's something you can try for lots of proofs. And also look to use it when you think you might have to do something that's impossible because of the infinite number of objects you're trying to address or make conclusions about. So that was 32. Okay, this is 33. They give us this figure here, and they tell us to express angle DAC in terms of alpha. So we don't have to know the degrees of this angle. We just have to express it in terms of alpha. Okay, so the most powerful word in mathematics, let. So let's label some things. Let and label both begin with the letter L. Let's label some things. So because this point here, we know this. So let's call this beta. And because this is an isosceles trigon, this angle here will be called beta. And just to make it easier, instead of talking about this angle here, let's refer to its measurement just as theta. And because this is an isosceles trigon, this right here is also theta. This is a linear pair, so we know this is 180 minus beta. All right, so looking at this, we have a few things going on here. We have this angle and this angle added together with this angle all give us 180. So we have theta and another theta, so 2 theta plus that angle gives us 180. And this angle here, we're calling 180 minus beta. 180 minus beta. So take the parentheses off, so we have 2 theta plus 180 minus beta equals 180. That means if we add the opposite of 180 to each side, we get 2 theta minus beta equals 0. 2 theta is equal to beta. So that means here we have beta and here we have beta. We can replace that with 2 theta. There's our 2 theta. And let's introduce a new angle. And because now we're looking at this trigon here, and we're going to say that just to call this here, call this angle that angle there, let's call that omega. So we have a trigon with this angle omega, this theta, and this 2 theta. So if we look at omega here, angle ACD, we see it's a linear pair with alpha. So we could say that omega plus alpha is 180. Right? Because omega, we're calling the measurement of ACD. And this angle here, DC, I don't know, whatever, we could put E out here. These are linear pairs, supplementary. So add them together, you get 180. But we also know that 2 theta, this angle plus omega here is 180. So theta here plus 2 theta plus omega equals 180. There we go. These are both equal to 180. So by the axiom of the transitivity of congruence, since this is equal to 180 and this is equal to 180, these two things are equal to each other. So that means we'll write out the final equation like this. We have theta plus 2 theta plus omega is equal to 180, but we know 180 is equal to omega plus alpha. So if we add opposite of omega to each side, the omegas disappear. We have theta plus 2 theta, that's 3 theta equals alpha. So the measurement of angle DAC we're calling that measurement theta. We can see that theta Theta is equal to alpha over 3. Like so. That is number 33. On page, what page are we on? Page 47. Oh, that was 33A. Okay, there's a B coming up. Okay, so that was 33A. And I'm going to do 33B. And really, spoiler alert, you really shouldn't watch this one. I don't think you'll be glad that you did. 33B. Stop the video now, because you won't be happy with yourself. I don't think. If you like these puzzles, because you just did 33A. Look at this. See something? See something similar? Now, in 33B, they're asking us for this angle. Angle ECD. ECD, this angle here. And angle GEF. This angle here. GEF. Let's go for those two angles in terms of beta. Right here, you're asking for this angle here, which I call theta, but what angle DAC, this angle. You wanted this angle in terms of this angle. See where this angle is? Look at this isosceles trigon, this angle. They wanted this angle in terms of this angle. And here, isosceles trigon. Now they're asking for this angle in terms of this one. Look how similar these are. So how do you think you might do this angle? Because you should already be thinking that this angle is pretty much the same. Because 33 is asking for this one, 33B. 33B is asking for this angle here and this angle here. Now this angle is pretty much exactly the same as 33A. Except now we're switching, instead of writing this angle in terms of this one. Now here they're asking, write this angle in terms of this one. Okay, so stop right here if you don't want any more spoilers. Because here it comes. Are you ready? This right here, this angle here that we're supposed to find, is 3 beta. Yeah, 3 beta. I don't need to do any other work. You can come to this conclusion that fast because of 33A. Do you think these are similar somehow? Angle DAC, in terms of alpha, the measurement of DAC is 1/3 alpha. It's alpha over 3. Here they want this angle in terms of this angle here. This is 3 beta. If you have questions on that, ask me in class. We really need to go over that. I'm not going to solve it completely here, because there's nothing really to solve. It's one step. Look, it's the same situation. Now, these might not be congruent. They won't even be similar. Not even the same shape, not the same size. But it's the same situation. So there's this relationship, this proportional relationship in here and here. So doing GEF. Okay, how do you think we might do that? How would you think we might do that? Well, very similar to how we did this. How we got this. I'll even use the same symbol. Use the same colored pencil over here. Okay, so what we'll do is we're going to find... Oh, this is not the same colored pencil. Here's the blue one. Okay. So let's make this. Let's call that omega. That angle right there. And this is the angle we're trying to find. So we know that because this is an isosceles trigon, that part of this angle omega is equal to 3 beta. Do I have... I need a pencil sharpener. Where'd my pencil sharpener go? We'll be right back. Okay. This thing right here, this G angle GEF, let's give it a much more simple name. Let's call it alpha. And this is alpha. There we got alpha. Now, what are we using? We're using the most powerful word in mathematics, let. And of course, label starts with the same letter as let. Let and label. We're going to label some more angles here. We got to have something more than what we have here already. All right, we're going to do something similar to what we did here in 33A. So we have this. We have an isosceles trigon here next to the angle we're looking for, or the angle in question. So let's label this theta, and this is theta down at the bottom. Theta and theta. That makes part of omega. Part of omega is 3 beta, right? 3 beta plus, well, plus this angle here inside this vertex angle of the isosceles trigon, plus this angle. Well, this angle is 180 minus 2 theta. Plus 180 minus 2 theta. 3 beta, because this is an isosceles trigon as well, so this here is 3 beta inside there. The omega is all of this. Or we're just separating this and this. So 3 beta plus this angle, which is 180 minus 2 theta, plus alpha, There's alpha. That puts me back on this line. Right? If I start rotating this way through these angles, I get 3 beta, and then 180 minus 2 theta, and then this alpha, and that's all 180. And we can also write 3 beta plus 180 minus 2 theta, that is our omega. Kind of cramped for space here, unfortunately. Now we know that beta plus theta plus omega plus theta plus omega is 180, because we have a trigon here. And this trigon. It's a little trigon here. So we're using all of omega. Right, beta. In this corner, we just have 1 theta. So beta plus theta plus omega equals 180. So that means omega. All right, look, are you sure you want to continue with this? Are you sure? Stop the video now. Don't watch to the end. You can get it. This is beta, or omega is 180 minus theta minus beta. And what else is omega? It's 3 beta plus 180 minus 2 theta. So that means 180 minus theta minus beta, which is equal to omega, is equal to omega, which is also 3 beta plus 180 minus 2 theta. Take the parentheses off here, and we have 3 beta plus 180 minus 2 theta. 180 minus theta minus beta. Add the opposite of 180 to both sides. If we add the opposite of 180 to both sides, these will turn to 0, disappear. And here we'll have, so let's assume we did that. I don't have the space to write it, so maybe I'm skipping a line of algebra. I really should write. Here, let's do this. So we have 180 minus theta minus beta equals 3 beta plus 180 minus 2 theta. So add the opposite of 180 on each side. Like that. So here we have 0, negative theta, let's see, negative 180 and a positive 180 is 0. Here we have 3 beta minus 2 theta. So let's add, let's move this beta, let's add beta to each side. So negative theta minus beta plus beta, 3 beta plus beta. There's our minus 2 theta. So now over here we just have negative theta. Over here we have 4 beta. Add 2 Let's add 2 theta. If this is true, then we can do this. 2 theta to each side. So here we have those betas going away. And this would be just our theta. 2 theta plus 1 negative theta equals theta. So theta is equal to 4 beta. Theta is equal to 4 beta. So that means we're looking at this situation here. This theta, these thetas are actually 4 beta. Theta is 4 beta. Okay, so we're going back to this line. All right, and this line, it looks like 2 lines. This line, you recall from here, isosceles trigon here, 3 beta and 3 beta. Remember, part of omega was 3 beta. So there's 3 beta. And this right here, this angle here, is 180 minus 2 theta, right? But we know that theta is 4 beta. So this is 180 minus 2 times theta, which is 2 times 4 beta, which is 8 beta. And then effectively what we're looking for is this angle. This is why you should stop the video right now. We're getting right to it. Right? This is alpha. So if we add this, because oops, do this. Right? There's this other 3 beta over here. So what's a good color for this? We're going for this in here. That one. So we know that 3 beta, some space, okay, 3 beta plus this angle plus that. So 3 beta plus that angle plus alpha, that equals 180. So 3 beta. Okay, we'll take the parentheses off of this. This is 180 minus 8 beta. So it's 3 beta plus 180 minus 8 beta plus this alpha equals 180. I ran out of space. This is a sloppy mess. I should get another piece of paper. Sharpener. So we have 180 on both sides, so those kind of go away. All right, because I'll add the opposite of 180 to each side, and it turns that to 0, turns this to the additive identity, which is 0. Add the additive inverses, get the additive identity. So this is 3 beta. Let's see, in this, writing this line, I'm going to add the opposite. So these are going to just disappear. And I'm going to write 3 beta minus 8 beta. And that 180 is gone. Plus alpha equals 0. Negative 5 beta equals negative alpha. 5 beta equals alpha. Alpha is what we're going for. This is angle, what they call it, GEF. And that's the one we need to find, GEF. 5 beta. I gave you the spoiler alert. You should have known it's coming. It is pretty much the same thing as pretty much the same thing as here we go, 33A. And this is 33B, 34. I'm not going to do that. 34, no. I've done enough. 34, that's a challenge for you in this book. And also the others on that page. So what are we, page 47? These right here, these, the rest on page 47, they're the first few of the easy level. So, nah, I'm not even gonna, we're just gonna end page 47 right here. All right. So we'll start with, next video, start right up here with 48. This has been Puzzles and Plane Geometry.